Graph the function and describe the transformation. Write the equation for any asymptotes and state the domain and range. So first, let's find the horizontal asymptote. In order to find the horizontal asymptote, we're going to look at the graph. Notice how the graph was moved down 2 units. That means the horizontal asymptote is y equals -2, which is basically the vertical shift. Because this is an exponential function, so let me just graph the parent function. It's going to look something like this. That is the parent function 2 to the x power. So we are interested in horizontal asymptotes. We do not have vertical asymptotes. The domain of this function, the exponential function in general, is from -infinity to +infinity. The range, however, is going to be affected by the asymptote. So first, let me graph that asymptote. X is equal to -2, y equals -2 is approximately here. This point is going to be shifting. However, because we have a horizontal shift as well, we are not able to figure that out exactly. So we're going to just try to find the x-intercept. In order to find the x-intercept, you're going to put y, or f of x is equal to 0, and solve. So we're going to put y equals to 0. So we have 0 equals 2 to the x minus 3 minus 2. We're going to add 2 to both sides of the equation. So we will end up with 2 equals 2 to the x minus 3. Because we have the same basis, that means the exponents are the same. If it's not there, it's equal to 1. So you're going to say x minus 3 equals 1. Add 3, you get x is equal to 4. So the point is 4 and 0. The x-intercept is 4 and 0, which is approximately here. I wouldn't try to find the y-intercept because the process is going to yield a fraction. And it's not the greatest way to graph that, so the graph is going to look something like this. I will just depend on the x-intercept in this case. So this is the graph of f of x, which is this function after the 2 transformations. Now from the graph you can see clearly that the range is from -2 to +infinity, not including the asymptote, because the asymptote, the graph doesn't touch at all. Graph the function and describe the transformation. I forgot to describe the transformations.
So the function moved 2 to the x, moved down 2 units, and to the right 3 units, or 3 units to the right.
Number 33, graph the function and describe the transformation. Write an equation for an asymptote and state the domain and range. Because we have the logarithmic function, the parent logarithmic function is going to have this as an asymptote, the y-axis. And the parent function for logarithms is going to look like that. So log any base, let's say of 2 of x, is going to look like this. So that is the parent function. This parent function, so
the function moved up, and let me define the function, log base 2 of x, moved up 2 units, 1 unit, sorry, and to the left 4 units.
So that is the transformation basically. We don't have any other transformation. So we want to find a vertical asymptote. Since it moved to the left 4 units, this function moved to the left 4 units, we're going to take the argument and make it equal to 0 to find the asymptote. So we're going to say x plus 4 equals to 0 to find that asymptote. And we get the asymptote equals -4. So x equals -4 is our vertical asymptote. Next step, we need to find other few points. We're going to make the argument equals to 1. And that will give me x is equal to -3. Now I will plug that back into f of x. So f of negative 3 is equal to log base 2 of negative 3 plus 4 plus 1. This is going to become 0 plus 1. So y equals 1. So the point is negative 3 and 1. Similarly, I will go ahead and erase what I just did here to find these two values. So after that process, after putting x plus 4 equals 1, I got x is equal to negative 3 and y equals to 1. So the point was negative 3 and 1. I will do this process again by making x plus 4 equals the base, which is in my case 2. So now I'm going to solve for x. So x is equal to negative 2. And now I will find y by plugging it back into f of x. So I have log base 2 of negative 2 plus 4 is 2 plus 1. This is equal to 1. So 1 plus 1 is 2. So y is equal to 2. So the point is going to be negative 2 and 2. So I have the vertical asymptote. And I have 1, 2 points. Now it's time to graph. Let me just put the asymptote here. The domain for the logarithmic function is going to depend on the horizontal shift. So let me just graph it first and then we will determine the domain and range. The range is always from negative infinity to positive infinity. It doesn't get affected by the vertical shift. The domain. So first we're going to graph x is equal to negative 4, which is the asymptote, vertical asymptote. And then we're going to find the 2 points. The 2 points are negative 3 and 1. Negative 3 and 1 is approximately here. Negative 2 and 2. Negative 2 and 2 is approximately here. So the graph is going to look something like this. So as you can see, the domain is from negative 4 to positive infinity, which is basically from the vertical asymptote to positive infinity. There is no reflection, which means it was not affected by reflection. It was not affected by the vertical shift.